Hi, this is David Voss, CCIE 11372, and in this video you're going to learn about dial-up technology. We're going to do an overview of ISDN technology and then dig into some of the details such as ISDN BRI and PRI. So let's begin. Although dial-up technologies are not very common in today's modern network, it is a topic you can expect to see on the CCDA certification. Dial-up falls under the category of circuit switching, and it uses the public switch telephone network, or PSTN. A connection is established when a user wants to use the dial-up option, and the connection ends when the user is done using the link. Considering dial-up connections use an analog signal, users need to use a modem in order to take the digital signal from the computer and then convert it into analog communication on the PSTN and vice versa. Dial-up access offers very limited bandwidth capabilities, but its advantage is that it's available just about everywhere because obviously PSTNs span across almost every geographical location. The technologies used over the PSTN should not utilize much bandwidth. Modern networks may use dial-up technology as a backup connection that can be activated in an emergency when no other WAN connection type is available. And this is one of the most popular uses of ISDN, or was in the past especially, was as a backup connection should the WAN connection fail. Now, ISDN is a technology that allows digital communication over a traditional analog phone line so that both voice and data can be transmitted digitally over the PSTN. ISDN never reached the level of popularity it was expected to because it emerged when alternate technologies were also being developed. The two flavors of ISDN include ISDN BRI Basic Rate Interface and ISDN PRI Primary Rate Interface. ISDN BRI connectivity contains 2B bearer channels for carrying data and 1D delta channel for signaling, and is abbreviated as 2B plus D. Each of these bearer channels in the ISDN operates at a speed of 64 kilobits per second. Multi-link PPP can be configured on top of these interfaces to allow the user to reach a bandwidth total of 128 kilobits per second. This bandwidth is considered very low, obviously, according to modern network requirements. The delta channel in ISDN BRI is a dedicated 16 kilobit per second traffic control. There are also 48 kilobits per second overall for framing control and other overhead in the ISDN environment. Therefore, the total ISDN bandwidth for PRI is 192 kilobits per second, 128 kilobits per second from the B channels, plus 16 for the D channel, plus 48 of overhead. ISDN PRI has 23 B channels and 1 D channel in the United States and Japan. The bearer channels and the delta channels all support 64 kilobits per second, including overhead. The total PRI bandwidth is 1.544 megabits per second. In other parts of the world, like Europe and Australia, the PRI connection is 30 B channels and 1 D channel, and therefore you have more bandwidth as well. The ISDN technologies we've been describing are called TDM, or time division multiplexing technologies. TDM refers to being able to combine multiple channels over a single overall transmission medium and using these different channels for voice, video, and data. Time division refers to splitting the connection into small windows of time for various communication channels. ISDN speaking devices are called terminal emulation equipment, and they can be categorized as either native ISDN or non-native ISDN equipment. Native ISDN equipment is comprised of devices that were built to be ISDN ready, and they are called TE1 devices, Terminal Equipment 1. Non-native ISDN equipment is comprised of TE2 devices. Non-native ISDN equipment can be integrated with native ISDN equipment by using a special TA, or terminal adapter, which only TE2 devices require. The ISDN service provider uses termination devices called NT1s, or Network Termination 1, and NT2, Network Termination 2. These are translation devices for media, transforming 5-wire connections into 2-wire connections. The local loop is the 2-wire connection. It's a 2-wire link for users. In North America, the customer is responsible for the NT1 device, while in other parts of the world, this falls under the service provider's responsibility. Because of this issue, some Cisco routers provide built-in NT1 functionality that features a visible U under the port so the user can see this capability quickly. The U notation is found in the ISDN reference point terminology. These reference points are important for troubleshooting or maintaining issues in an ISDN network. The ISDN switch is usually located at the service provider's location. The different ISDN reference points are as follows. The U reference point is between the ISDN switch and the NT1 device. The T reference point is between the NT2 device and the NT1 device. The S reference point is between the terminals TE1 or the TA and the NT2 device. The R reference point is between non-ISDN native devices and TAs. So here's what you've learned. You've learned a basic overview of ISDN. You've gotten also granular enough with learning about ISDN BRI and then PRI and the different types of ISDN equipment that you should be able to answer correctly any ISDN related question on the CCDA exam. I wish you the best of luck in your studies. Thank you.